places we are in wireless mode. Maybe you are connected in a LAN, I am connected in a LAN. To some part, we are connected in wired, but 99% we are connected wirelessly. It is happening, or it happened only because of this eminent personality, Marconi, who had the thought or the vision of sending the data in a wireless medium. So this was the first recorded wireless transmission, and today we see lots of evolution in smartphones, Bluetooth, Wi-Fi. So many things are there where we cannot live our life properly without internet or without a mobile phone. We can still live as a human being, but the world is becoming in such a manner like we cannot exist or we cannot live properly. Suppose, see, we are maybe I am 40 years old, so my age people can still live, but you go to any kindergarten school children, they will cry if you don't give mobile to them, right? It's a different debate altogether, but that is the world what we are living, and only because of such kind of technology evolution during pandemic time we are able to continue our education system. There will be so many debates whether online is good or offline is good, but at least because of the technology or the evolution in technology, we were able to handle the pandemic period also in a successful manner, right? In one side of the coin, I am talking. Then there is another person. This person is the first man who got a vision to speak to someone when he is going in a car. He is the person with a team of people in Motorola. He is Martin Cooper. So his vision was, can I speak to somebody when I am moving in car? Mobility concept came from his team, and during the late 90s, we all know, right? We know that 2G phone or one, there was no 1G. Only before that was, or when that second generation came, people termed the previous one as 1G, but there was no official term called as 1G, right? Now you can see this person's uh, vision has given us different set of mobile phones, right? And the first commercial cell phone, you know why it is called as a cell phone? Because the area is virtually divided into a hexagonal shape called as a cell. That's why it is called as a mobile phone. Mobile means mobility or the ability to move, right? When we are able to communicate, uh, when we are mobile in nature, that's what we say it as a mobile phone. He is the person who has invented it. Okay, so from here, these two persons, right? There are so many eminent professors who has contributed to a enormous manner, but these two, I am just considering that the pioneers who started revolution in technology in two different aspects. The first guy wants to communicate in a wireless medium. The second guy wants to communicate in a phone while moving. So this is the mobile phone, the symbol you can see in the right hand side. This is the mobile phone. It is gigantic in nature when you compare it to the miniature smartphones nowadays, what we have, the handheld devices. Earlier, it was huge in size, and the complete system was analog signals, right? And it was called as advanced mobile phone system. Advanced not now. During that time, it was called as advanced because during those days, people were not even thinking about talking to somebody while they are moving in a car, right? And just I will roughly go through oh sorry, the features of the first generation system. As you know, it was very limited in nature with respect to the text. There was no concept of sending text in first generation of mobile phone system. Different frequencies were used, and the technology is completely analog switching, and people used to use frequency modulation. That means one frequency will be divided, and every it means in every channel one of the communication used to happen. And the access technique, as you know already, right now also we know frequency division multiple access. That means the frequency is divided into various band, and you will get, for example, we think that I am the only, suppose if I am calling to somebody, I think that I am the only person who is talking, but not the case. Many people will be talking parallelly. So this is the access technique that was used. Then you know this mobile. I think if you are a faculty of my age, definitely you might have at least used this kind of phone. This, I am not promoting Nokia mobile here, but this is the mobile which we know as the 2G mobile. Like, it is called as, technically it is called as GSM. The architecture is called as GSM, that is Global System for Mobile Communication. This is the place where people started using the mobile phone in a more systematic manner, you can say. What is systematic manner? I will tell you. For example, let us come to the first generation. In first generation, there was no global standard. For example, America will have their own system, Japan will have their own system, means every country will have their own system. So later on, when the technology is being evolved, they started a global system. That's why the GSM starts with the word global system. Why? Because it's the standard where all the people agreed upon and they started developing and working together. So this is emerged from the Bell Laboratories, and digital technology started into, means coming into picture only from the second generation onwards. So it is basically a digital switching technology. That's why we say digital cellular technology. Now from second generation onwards, to some extent, data services also started, not to a great extent. And many of you, for example, if you go to any person who does not know anything about mobile communication, who does not know about any networking, you go and ask, why I have to take 5G SIM card? They will immediately tell speed. Everybody will say speed. Why? Because a common man understands various generations of mobile system with respect to the data rates only. For example, I think you might have used the third generation SIM card. You might have, I am using 4G, fourth generation SIM card now. I am yet to take 5G because it is not completely available for us, right? So why we are upgrading ourselves? If you ask a normal person, like non-technical person, they will say 2G से 3G बहुत बेहतर है, 3G से 4G बहुत बेहतर है. Oh, sorry. I mean to say, they will say that it's more of like getting good speed. If you want to watch a movie, don't use 3G mobile SIM card, but use 4G. If you want to watch further, like when you are, they will say you upgrade yourself. Why? They will say because the common man knows only one thing, that is improvisation of the data rates. How the data rates got improvised, it is not improvising by itself, right? There will be some technology for that, right? As a computer science faculty or from any ECE background faculty, we understand what is a circuit switched system and what is a packet switch system, right? For example, before connecting to us, 5 minutes before I got connected, I asked, am I audible? Madam, my screen is shared. Why we are asking these kind of handshaking? These are some handshaking signals, right? Before starting the presentation, we all got connected, and once the connection is established, unless until there is some kind of disturbance in network, we are all connected together. So this is one example of a circuit switch system where the 2G system used to adopt. For voice communication, there used to be a dedicated link established. Dedicated link need not be a wired link. Dedicated link may be a virtual link which is created for that particular duration of time. Initially, in second generation, they used to use the access technology, that is time division multiple access. The time slots are divided into 8 channels, and during that particular time slot, data used to get transmitted. That is the technology that they used. So there are the different frequencies are there. As I said, technology was digital switching. Let us not go deep into the modulation techniques, right? And yeah, Gaussian minimum shift keying is used, right? And the access technique is time division multiple access. As I said, the existing time channel is divided into 8 25 kilohertz time slots, and communication used to happen. And if you talk about the data rate, it is unimaginable where we are right now. When you go back, it was like hardly kilobits per second or megabits per second, ideally, right? It is very tough to imagine watching a movie with a 2G network, right? Now, there was no security aspect in first generation, whereas A3, A5, there are the unanimous uh, anonymity of a user, or the nobody will know exactly if you tap. Ideally, people will not know from where the call is coming, right? Ethically, if you watch, there are so many cases where people are tapping the phone. That's a different thing, but there are so many algorithms. Initially, the security aspect or the encrypted voice transmission started with A3 and A5 algorithms, right? From 2G only. Then here I would like to ask a small question, right? You can unmute now and tell me, sending SMS is data or voice? I just want to ask now, because I spoke for at least 10 minutes. It will be good if I can hear from the faculty. Can somebody say short message service, SMS, whether it is a voice or a data service? I just want to hear from you. Can somebody please unmute? If somebody speaks, that is an indication that you are with me. If nobody is responding, means
Hello, sir.
yes, sir. Yes, sir. Yes,
Sir,
sir.
am I audible, sir?
Yeah, audible, sir. Audible,
Sir,
sir.
Buji Babu, sir.
Yes,
Sir,
sir.
actually, anything which we are transmitting is, though it is a kind of message, but during the transmission, it is definitely a data, sir. Without
Okay.
converting that information into data, I couldn't able to transmit, sir.
Okay. 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 Anybody else? Just want to listen from you for a minute. Thank you, Buji Babu, sir. Anybody else? Whether SMS service is voice or data? Or I will just tell you, only one person has responded. Okay. In 2G system, the SMS service, though it is data, but it is sent on one of the 8 time slots where you are seeing in my slide. One of the time slot of voice communication is used to send SMS. That's why it is not a pure data service. Why? It's data. I will agree to some extent with Bujibabu, sir. It is definitely data, but it is not a complete data service. I will tell one example. You cannot send hello without internet in WhatsApp, but you can still send hello in SMS without internet in the mobile. Why? Because it is not using the data channel, rather it is using the voice channel. I'm just telling about the 2G time, and even if it is 3G or 4G, without internet I can send SMS, but without internet I cannot send the same content in WhatsApp. Why? Because WhatsApp is purely a data service, whereas the SMS is not completely a data service. And during those days, it came into existence from 2G onwards, and then in 2G time only, we got the internet with very, very low data rates. That I will not completely go through this particular slide, but now also I am not sure, because you people are sitting in a much developed places than me. Sometimes right now in my mobile 4G is coming, but in NIT Nagaland, if I go to some places, I think you are able to understand what I am saying. In the RSSI, where the 4-tower signals will come, no signal strength will be indicated with 4 or 5 bars. There you can see sometimes, I'm not sure whether you feel, but I will see sometimes I will get G, sometimes I will get E, sometimes I will get 3G, sometimes you will get H plus. There are so many meanings for that. That G is coming from the GPRS-G, General Packet Radio System. What is this? Okay. Here also the modulation technique is Gaussian minimum shift key. Like, let us not go so much of details, but I want to tell you the difference in terms of a diagram. Okay. The basic 2G architecture without the existence of internet in mobile, that is data services, looks something like this. For example, BTS is base transmitting station or base station. This is the first point of contact in the wireless medium for any mobile device. We say tower. It is technically not a tower, but colloquially people use mobile tower. Okay, that is nothing but an antenna. So many systems will be there, server will be there, so many things are involved, and this particular base station is the first point of contact for your mobile. Such kind of base stations are connected to another device called as base station controller. From there, it is going to connect to mobile switching center. Mobile switching center will have two important databases called as home location register and visitor location register. It is very simple. I am using Vodafone Northeast SIM card, but whenever I am coming to my hometown, immediately many of you know R will come roaming. How come that R is coming? For example, being a Vodafone Northeast customer, my database is with the HLR of my mobile switching center in particular area which Vodafone is managing. But the moment I switch off my mobile in the flight, and when I switched on again in Kolkata, and or I will switch off in Kolkata, and when I land in Hyderabad, immediately after some time you will get welcome to Vodafone West Bengal or welcome to Vodafone AP and Telangana. What are those terms? They are called as PLMN area, Public Land Mobile Network Area. From one mobile network area, if you are going to another mobile network area, for example, imagine two things here. One is Northeast network, another one is Telangana network or Andhra Pradesh network. Here I am having the data in HLR. When I go there and when I am, how I am getting or how I am being recognized as an authenticated customer. You know how I am going to get recognized? My mobile will catch and send signals to the nearest Vodafone and so many other towers also. Let us colloquially talk as a layman. There is a tower for Vodafone, Airtel, everything. My mobile, even though I belong to Vodafone, it will be able to recognize all the things. I think if you don't believe me, you go stop the access point and search manually. You will see all the things that just because you are using Vodafone, that does not mean it will not recognize Airtel base station. It will recognize everything, but when they came to know, right, there was now because of mobile number portability, we are not able to identify the difference between a particular network. But ideally, earlier days, when you are using your 2G phone or 3G phone, Vodafone will have one particular series. Airtel will have another particular series. Okay, that's a different thing where we can. I'm not here to talk about mobile number portability, but I just want to tell you when my signals are being communicated to various base stations, one of the base station will identify this person looks like my person, but he is not in my HLR. So what that will do, for example, if I am going to Vijayawada, then one of the BTS will try to contact to its BSC and its MSC, and via the gateway, it will reach my Vodafone Northeast MSC, and finally from my HLR of Northeast Vodafone, it will take the entry and it will keep in Vijayawada's areas VLR. That's where R will come, and that's why people used to charge for roaming. Nowadays, incoming roaming is free. But earlier, you go to our childhood days, right? Even if you are picking a phone in roaming, they used to charge. Only in the last decade, they have changed the policies. But earlier, even that's why people never used to pick even the call when they are in roaming. Why they are charging more? Because your traffic is being diverted from many infrastructural devices. Okay, so now coming to the data services, right? So here GMSC is basically is a gateway, and PSTN is the public switched telephone network, which is the initial stages. You know what is the landline network, right? One of the name for landline technical name is PSTN. Now data and voice are going in the same channel. Later on, when the 2.5G, the so-called GPRS, are not GPS, GPRS, General Packet Radio System, here people started changing the route. For example, you can see some more additional infrastructural elements came, SGSN and GGSN. Okay, serving gateway support node and gateway support node. These things are introduced to divert the voice data and the packet data. Now you can clearly recognize in 2G there is only PSTN, but later on you can see a cloud where it is written as packet data network. Internet is one example of PDN, packet data network. Here, in case if you are using any voice, it will come to from the mobile, it will come to BTS, go to BSC, come to the SGSN, GGSN, and go to packet data network. So by using this, automatically you are getting an enhanced data rates, and later you can see sometimes in the signal E, ABCDE. E stands for edge. Edge means enhanced data for GSM environment. What this, I will tell you a simple example. What is modulation here? You have a suitcase where it will take 5 pair of clothes. But sometimes we will push some more additional pair of clothes, yes or no? Definitely, many times you might have done that. That is what they have done in a simple way to understand. The modulation was octagonal phase shift keying. So here they used to pack 3 bits per symbol. That means it is something like you are packing more clothes within the same baggage or the suitcase where you can carry more data inside that in a simple terminology, right? Then automatically 3 times the data rates were increased in Edge. Edge and GPRS uses the same technology, other than the only difference is the modulation here. Now there obviously when you are packing more bits, then obviously you are carrying more data. When you carry more data, the data rates will increase. Then you know the 3G mobile or the 3G system. Here, yeah, in 2G also, in 2G I forgot to tell you, for voice data circuit switching system was used. For packet, for data services, packet switching was used. Now, to be very honest, 3G in India was a failure. Why? Because 3G required new frequencies, and because of that, they have to install new infrastructural elements. That's why I am not sure how many of you have used. There was a different 3G SIM card also. Okay, it used to be very big also, right? So some advanced multimedia access came into existence only from the 3G. Okay, video calls came, not the video call which we are using right now, but there were so many video calls which started in the 3G standard onwards. And you know, GPS, where many people are tracking now. Nowadays, many devices have GPS sensor in that, but it started in 3G system and some location-based services. Okay. I will show you the additional infrastructure elements also, because I have to rush through the past. Whatever I am saying right now is the past. And right now, this slide is the present. We are in completely a 4G network era right now. And we are going to, or we are trying to
Excuse me,
go
sir.
into, yes, madam.
Sir, are you sharing any PPT, sir?
Yeah, I shared my entire screen, madam.
No, sir. Only we are.
Ma'am, you should have told me long back. Oh, I'm thinking that I shared my screen, madam.
No, sir.
Oh, the
Nothing.
presentation.
Yes, sir.
Oh, I'm extremely, ma'am. Thank you, madam.
Okay, sir. Thank you. Sir.
Oh, I'm extremely sorry, madam. It will be very boring if you are unable to see. Thank you, madam. At least you reminded me. Are you able to see my screen now? Madam, please confirm. Are you
Yes,
able to see
yes, sir.
this?
Yes, sir. It's
I
visible,
am
sir.
extremely, yeah, I'm extremely sorry, participants. I just want to, I will, just give me 30 seconds. I will just show the slides what I explained. Okay.
Okay, sir.
Let us not go to the, yeah, I will not explain again, but let me just show. 1 second. Yeah, this is the one I just spoke about, the second generation and the 2.5, where you can see in 2.5 there is PSTN and packet data network, one for voice, the lower one was for the data services. Now coming back to, I already explained some things.
Sir, again, the screen is not visible, sir.
Madam, I shared the screen. Madam, what I understand is after I start my presentation, automatically it is getting disabled. I am not sure, madam. Never come across such scenario. Let me do one thing, madam. I will. Sure, why it is coming like this? Automatically it is getting disabled. Let me just cancel the sharing and share once again. Open share tray. Screen, entire screen I am sharing, madam.
Yes, sir. It's visible, sir. Now.
Okay. Okay. Yeah. Now you can see the evolution where we are right now. We are into 4G networks. The only difference between, not the only difference, there are so many differences, but the major difference started here is till third generation, voice was sent on circuit switch, data is sent on packet switch. But now in 4G, if you can remember at least 4 to 5 years back, whenever you are buying a 4G mobile, people used to sell Volt is there, Volt, VoLTE, voice over LTE
Sir, your
network.
voice is not coming.
Madam, I am connected to dedicated LAN Ethernet port. Madam, my data rates are completely fine, madam. I am connected to Ethernet port. I'm not sure why. Maybe sometimes, madam, during the receive end, in case if your internet is not good, then my voice may not be clear to you. All other participants,
Okay,
everybody is facing the same problem that my voice is not clear?
No, sir. No, sir. For me,
Okay.
your voice is clear, sir.
Oh, that means there may be a chance, madam, that maybe in at your end also there might be a problem in the. Okay.
sir.
Okay, fine. Now, from 4G onwards, whenever we are purchasing any 4G mobile 5 years ago or such time, people used to say there is a feature called as Volt, VOLTE. The person who is selling may not know what is it, but he used to sell, sir, Volt is enabled. That is voice over LTE network. LTE stands for long-term evolution. Basically, LTE is not true 4G. LTE advanced is the true 4G. Here, what happened is they have eradicated the concept of circuit switched system for voice, and everything became flat IP network where your voice is also sent over the packet switched network. That's why I'm not opening a debate. That's why Zio has come up with so many freebie concept initially, and you know what happened now. Because of that, all the other companies also reduced the rates, and we used to get lots of data for a cheaper price when compared to what we used to pay in 2G or 3G. So basically, this is completely IP based cellular communication. As I said, the voice, data, everything is sent over the IP packet switched network only. And higher data rates were by default offered because they will change the modulation techniques and all, right? Now we will talk about heterogeneous network areas. Heterogeneous means different. What is heterogeneous with respect to network is, right now, in some places in NIT Nagaland, I will get only 2G signals. Some places in NIT Nagaland, I will get only 3G signals. Most of the places, I will get 4G signals. This is one example of heterogeneous network. Not only the generation differences, I will explain very soon what are different network elements or network areas with respect to heterogeneous word. Okay. So when 4G came, you know, right now I am using the 4G mobile right now, 4G SIM card, 4G mobile, everything, right? This is particularly a streaming era where everything can be streamed with less amount of time, right? But there are some more challenges with 4G, right? Which has given birth to 5G. I would like to tell you, like in Government of India, every 10 years there will be a pay commission. Similarly,
Excuse me, sir.
yes, madam. Yes, madam.
PPT, sir. So,
Madam,
one thing you
I
can
will do one. I will share with you, madam.
and
Okay, okay, madam.
that will be fine.
So
Exhibit
first
is
time,
for
madam, I
supporting
am.
sharing.
Yeah, I can understand, madam. First time I am
Please
seeing
send
such
me mail
issue.
what I can share.
1 second. So give me a moment. I will definitely share the slide deck, madam, now itself. First time I have taken classes earlier in Microsoft Teams, but anyways, I am sending Suma, Suma madam, in your WhatsApp, madam.
WhatsApp also fine. WhatsApp also fine.
Yeah. I'm sending, madam. I'm sending.
Dear part.
WhatsApp is.
YouTube link to the WhatsApp group. You can watch in the WhatsApp group also. YouTube also. YouTube live. If you are not comfortable, if you are also having the internet issues, you can follow the YouTube also. Right.
Madam, I have shared with you, madam.
you have shared in the WhatsApp group?
In your WhatsApp, madam.
Yeah, okay,
In
sir.
your WhatsApp. Not sure why I'm sharing the screen. Automatically, after some time, it is getting disabled. Anyways, I will wait for your sharing. Yeah, in the meantime, before Madam shares, some people may get a doubt. Why should we understand all the generations before learning about what 5G is going to offer and how it is going to impact Internet of Things? One reason I just to tell you, only when we understand what happened earlier, to some extent. See, we may not learn completely about the physical layer concepts because I am not sure, most of you may be from CSC background or IT background like me, but to some extent, if we understand, it will give us enough platform to set several objectives in guiding various students with respect to 5G or IoT, right? That is the only reason I have spent some time till 4G. Now, anyways, we are going to 5G system quickly, right? So I'm just waiting for Madam to share the slide decks. And in case you can share the feedback till now, almost 1 hour is over. Another 2 hours is there with a small tea break or kind of a pause. So you can tell me, like the way I am explaining, is it fine? The flow, is it going fine? Are you able to find it informative, or do I need to change the style in which I am explaining? You are feel free to inform me, because anyways, Madam has to download and Madam has to share. By the time we can have a small feedback, mini feedback session. The way I am explaining, is it fine, or is it okay, or do I need to change the style or anything? If nobody responds, you know, you are also a teacher in online mode, student does not respond, then we feel that nobody is listening to us. So kindly respond either yes or no, something like that.
Hi, sir.
Hello, sir.
Sir, it is good, sir. Delivery and voice, everything is good, sir. But only we need to have your slide parallel presentation during the delivery, sir.
Yes, sir. I apologize. Yeah. Thank you, sir. Thank you for your feedback. Anyways, sir, that's why we gave a pause. Madam is going to share. Not sure, sir. Automatically, it is getting disabled. I shared my entire screen. I started my presentation. Automatically, it is getting disabled. Not sure why. Anyways, Madam is going to share that. Thank you for your feedback, sir. I too agree. If I am not able to share the screen, and if I am keep on talking, then you cannot see. You will not be able to get the same fruit what I am expecting. That's correct, sir. I agree with you.
Thank you, sir.
Some technical issues with the Microsoft team, which they have shared, I think so, because in NIT Nagaland, we also use Microsoft Teams. I have an account, so no idea. Okay, quickly, can we take a 5 minutes break? Just a 5-minute quick break so that you can also get refreshed. The time is 3:05. We start again. 4 minutes, we'll take a small break. By the time Madam will share. Okay, I think Madam is able to share my screen. Ma'am, you can go to the slide where it shows about 4G, Madam. don't remember the exact slide number, but maybe can you please go to the slide where 4G diagram is there? And then we will start exactly at 3.5. Hello. So let us resume our session. Madam, can you please go to the slide where the 4G diagram is there? Can you please move the slide, ma'am? I am unable to see. I am able to see only the first slide, title slide. Hello?
Yes, sir.
Yes, sir. Yes, sir. Please wait, sir. You have sent no. Please wait for us to respond. No. Please wait, sir. I just informed the students also. Sir, within. Yeah, sir, you said no, you have filled the form. But I think this is not a job offer, right? This is only for internship. Sir, can you please wait for some time, sir, for us to respond. Yeah. Sorry, madam. Madam, not the 15th slide, madam. You have come to 5G. Can you please go back to 13th slide or something like that? Slide number 14, no, 13. No, further. No, madam, not 12. Before that, I think 10th slide. I'm extremely sorry, madam. I'm giving a lot of trouble to you. Ma'am, 11th slide. Sorry, 11th slide. Eleventh slide, madam. Now, here you can see when you watch the slide here in 3G, completely the terminology also changed. For example, it was BTS, BSC, MSC. Now it became Universal Terrestrial Radio Access Network, and then Radio Network Controller. Means the way people perceived things changed, and there were new infrastructure elements like RNC, 3G MSC, 3G SGSN. That's why the 3G charges were a bit higher. Now, when you come to the 4G network, you can clearly identify in second generation, there was PSTN, no PDN. Now in 4G, and even if you take 5G also, no PSTN, only PDN, because completely the circuit switching technology is gone and people are using packet switching technique for sending the voice also. Okay, and if we talk about different layers, I will take a lot of time to explain, but let us skip the multiple layers here. Like what is EPC, Evolved Packet Core? Like there is a radio subsystem, network subsystem. Let us not go so much into the mobile communication details. I have given a rough idea about what happened to, means what happened till 1G to 4G. Now, ma'am, go to the next slide, madam. Slide 12, please. Now, just for a layman perspective, right? We know NFS game, like need for speed. Similarly, in first generation, the speed or the data rates, we should not say speed, it should be the data rate, the technical term. So it was only 2.4 kilobits per second, but whereas you can see now in fourth generation, it has increased, I don't know how many times, right? Almost like exponential growth is there where you can send 1 lakh kilobits per second, right, in fourth generation. So this is only a small comparison slide where you can see a person about to start, and now in 4G it is something like he's jumping from all the hurdles, right? Ma'am, next slide, please. Madam, what time we will take a 15-minute break, madam?
It's around 3:30.
3:30. Okay, so 20 minutes. Yeah, we have 20 minutes time. Now, most important concept. If you want to work on 5G networks, mandatorily you should know a concept called as macro cell and small cell. Okay, in a very simple manner, I will explain it. First of all, I just want to share my experience when I am working in Hewlett Packard and Tech Mahindra. Almost for 4 years, I worked on network management system on 2G femtocell and 3G femtocell. When I was about to work on 4G femtocell, I came to NIT Nagaland a decade back, right? Almost 10 years. By this October, I am going to. I have fair amount of idea about this macro cell. I will take a simple example. Everybody, please try to understand and follow me. In one of the place in Bangalore, I am not sure how many of you know about Bangalore. There is a place called as Madiwala. Okay, it is very near to Silk Board. One of the biggest junction you can say, where it connects to multiple places. Okay, why I am taking this example? So that you understand easily what is macro cell and why this home base station concept came, that is small cell or femtocell. I will ask one small question to you. We have 80 feet road. For example, we have 80 feet road. People were very happy with 80 feet road. Very good road, BT top is there, and nicely people are using lorry, car, pedestrians, two-wheeler, all the people are going. Now, that particular road became congested over the period of time. You know, in many areas it happens. Even in Andhra University, when I am studying, that Madhyapalam junction is a very big junction where it's a huge road. Now also it is very huge. But when I joined my BTech, it was little small, but increased. Now you can't further increase. I hope you understand what I'm saying. Just because the traffic is more, if you make the 80 feet as 120 feet, it may not solve the problem permanently. For example, in Bangalore, when I am saying about that Madiwala Junction, there is a place where you have a road, you have a subway, and you have a flyover. That means at the same junction, you have three different parts of the road. One goes underground, one goes normal level, one goes above the ground. Why such concept came? Why? Because they cannot extend. When they were unable to extend, what they have done? To just escape the traffic from the signal, they constructed flyover. After some time, there is another way going towards Koramangala. I'm just telling an example. Okay, same thing happens in network also. For example, consider IIT Madras. Many times we used to go to IIT Madras for various meetings for my research work also, right? In exactly opposite IIT Madras, there is a 200+ year old institution called as College of India, Anna University. Both are exactly opposite, and that area is a heavy crowded area. Now just imagine, whether it is 5G, whether it is 4G, or whatever generation which is going to come in the near future, every base station will have a theoretical limit. For example, let us talk in a very more colloquial language. A tower cannot give access to all the people nearby it at a same point of time. At a particular time instant, it will have a capacity. If it is beyond that, you know, call drop. Sometimes when you call will never connect. You know, call drop. Call drop. CALLDROP. Call drop happens because of this reason, because that particular base station is completely occupied. Now, why I quoted IIT Madras example is, IIT Madras is a huge campus. Number of students will be minimum 10,000 students, minimum. Anna University Gindi also is not less than that in the strength. They will also have so many students. Imagine people are using Vodafone, Airtel, Jio, etc., etc. So everybody will have a tower there. Now, what about the staff working there? What about the faculty working there? Staff family is staying inside the quarters. Research scholars are staying. There are so many shopkeepers. On the road also there is a Raj Bhavan in that particular area in Chennai. There is a Raj Bhavan, that is where the governor of Tamil Nadu resides. I hope you are able to understand what I am saying. There are some places, for example, you go to Hyderabad, the high-tech city area, Gachibowli area. You come to Bangalore, the electronic city area. I'm just quoting some example. Or Kolkata railway station, or Chennai Central railway station. There are some heavily dense areas, and there will be so many roads. For example, you take IIT Madras, Indy Road is there. Many people will be traveling on the road. Some people now, many people talk in the car by enabling their Bluetooth. Happily, they will be talking in the car and going. That means, what I mean to say, at a particular time instant, in one area which is highly dense, where you are constructing flyover, underpass, subpass, that pass, this pass, extension, extra roads, right? Similarly, how they can give access to as many people as they can. Just because they increase the spectrum is very costly. Okay, spectrum recently, the 5G spectrum also sold last year, right? Spectrum is very costly. In that particular band of frequency, Vodafone will get something, Jio will get something, Airtel will get something, BSNL will get something. In that particular band, what they got, they have to give to the lakhs of customers. And in that particular area, when your network is getting congested, how to escape the traffic? Like, for example, many times we see that in radio FM also it will come. One of the area is having traffic jam, so don't take this road, take a different route. In one of the movie called as July also, the hero uses the same technique, and he will divert the one of the villain to make sure the entire money goes to the bank. Example, I am just telling, not promoting the movie. So similarly, there is a concept called as offloading the traffic. What is offloading the traffic? From the macro cell. Then what is macro cell here? First we should understand. Till now, I showed some diagrams, right? It will connect to the base station. From there, it will connect to the base station controller or MSC. All the traditional channels are called as macro cell. Now, there were so many techniques called as micro cell, picocell, repeater, distributed antenna system. There are so many alternatives to macro cell, but one concept became more familiar, that is called as small cell, or you can also say it as home base station or femtocell. What is the advantage of this particular small cell and what it is going to do? I will tell you. Now we will see the diagram here. Okay. Femtocell looks like a Wi-Fi box. Looks like a Wi-Fi box. Here you can see in FemtoBS, in the left side of the diagram, you can see something called as FemtoBS. I think you will be able to point out where I am talking about. Femto base station is a miniature version of your macro cell, where the people who are registered under that particular femtocell, traffic will go directly to the mobile switching center or the core network of the mobile operator with use of the internet directly by escaping the macro traditional route. In a simple way, I will tell you. For example, IIT Madras has taken the femtocells. They may have multiple femtocells and they will be registered. Now the traffic inside the IIT Madras will not go to the actual tower which is geographically located near to that. Rather, via internet, it will directly go to the core network of the mobile operator. Then what will happen? Various advantages are there. First advantage is you are going to get the premium services because you are not waiting on the queue. It is very simple. If you are going to a hospital, right? Sometimes if you pay only some amount, you have to wait in a queue. But some hospitals will say priority counter. Priority counter, forget about hospital. You go to Indigo flight, okay? They will say fast forward priority counter. You pay more money, no need to wait in the queue. Directly you go. You pay some more money, your baggage will be given first when you are landing, after you land in one place. Similarly, you are going to get a premium service and you will get the best in class service because your traffic is not colliding with the outside traffic. And this will save lot of things in terms of energy also. I will tell one simple example. For example, let us charge the mobile 100% and sit in one place without watching anything, without using. For example, you will get 10 hours charge. Same thing, you charge 100%, sit in one car and start going. Don't use the mobile. Just sit in car. It will never come for 10 hours. It will drain out in 5 hours. Example I am telling. Why? Because your mobile is continuously sending signals to the nearest base station. So in that aspect, energy is disseminated, and automatically when you are going from one area towards another area, your mobile will have some handoff concept, like from one tower you are going to get to another tower. So in that way, what will happen? The amount of energy that it is disseminating is more. That's why when you are roaming, your mobile charge will come down even if you don't use the mobile. In the same manner, this particular femtocell is a miniature coverage area. You can say small cell means by the name itself, it is a small coverage area. When it is a small coverage area, your mobile need not spend lot of energy to connect to the outside macro cell network. Rather, it can use less energy. In that manner, you will get lot of energy efficiency also. But at the same time, there are so many other aspects where, sir, what will happen? From IIT Madras, slowly I am coming out. My work is over, I am coming out. Then what will happen, sir? Automatically, you will get disconnected from the femtocell and you will connect to the macro cell. Technology has evolved in such a manner that you will not realize anything. You will feel that you are enjoying all the services. This is the concept of home base station. So people want to use femtocells. Femtocells are there from 2G also. Why? Because I myself used to write the code in HP and Tech Mahindra for 2G and 3G femtocells. There is one more advantage of having a femtocell. You know, 3G network. I am talking about the past where I worked. The 3G network, especially in some areas like UK and all, the signal penetration strength is not so much. For example, I will tell in another why UK. I will tell our own example. Let us go to a shopping mall, huge shopping mall. Go to the cellar. Cellar will have basement 1, basement 2, basement 3. Did anyone get a proper signal there? Most likely we will not get a proper signal. Why? Why? Because it is unable to penetrate to that particular basement. Many times when we are in a lift, when we are in an elevator, you may not get the premium service. Similarly, in some parts of the world, there are some houses which are made of complete wooden structure. I am just telling an example. So there are various reasons that most of the communication happens indoor. This is the thumbnail or thumb rule. Mostly nobody will go to a outside area and speak. People will watch mobile from their bedroom. People will communicate inside a room. Sometimes we go out and speak, but most likely people will have communication indoor. Now, indoor will have so many obstacles. So if you are talking with the macro cell, through the macro cell only, one of the advantage of having a small station is, in case if you have something within your house, now you may think, why I am insisting more? This is the area where you can pursue many research activities. This is one of the potential area, because without this there is no 5G. I am going to show you that also. That's why I am emphasizing more on giving the background knowledge, what is a macro cell and whether really a femtocell is used in 5G or not, we will see now. Okay, so this particular small cell is also coming under heterogeneous network. Not only 2G, 3G, 4G. I said in the one of the slide, heterogeneous means different. Not that 2G, 3G, 4G is heterogeneous. It can be 4G with a small cell. That is also called as a, because the technology used here is different. The technology used in macro cell is different. Technology in 2G, 3G, 4G is different. All together form heterogeneous networks, which is the heart of the 5G, which is not completely on. 5G is there in many places, but not the entire world is not deployed with 5G as of now. Okay, madam, can you go to 14th slide, please? One of the example, like what will happen in case, can I have a femtocell in my house? Yes, absolutely. You can have a residential femtocell where, for example, this Ubiquitous is one of the femtocell product company. Like There is another company called as NEC. In UK, it is very famous. I worked for that client only for almost 4 years in HP and Tech Mahindra. That also provides femtocells. So you can have, for example, if Vodafone is giving femtocells, then you can purchase one femtocell from them, and you, with the use of the internet, your entire traffic at home will be completely means offloaded from the traditional traffic. So there are so many uses of femtocell. One of the uses, you can even have a residential femtocell where you will get, for example, nowadays, earlier people used to purchase an independent house, even if it is small. But now people are preferring gated communities, 1,000 houses, 3,000 houses, 10,000 houses. There will be a tower which is of 50 floors. Like that, there will be 100 towers. I hope you are able to understand what I'm saying. You go to Hyderabad, Mumbai, Delhi, Chennai, Bangalore. As of now, Vijayawada and all are not having so much of gated community, such kind of towers, but very soon it will also come. In that kind of places, these things can be used. Okay, ma'am, go to, I think it is 3:27. Madam, is it okay if we can take a small break and then go to the future about 5G and Internet of Things in the coming next session? Can we take a break, madam?
Please take 15 minutes break. After 15 minutes, the section will continue.
Okay, so okay, thank you, madam. So at 3:45, we will start again. In the next part, we will move to 5G and IoT. Thank you, madam. We will meet at 3:45.
Right. I use it. People use it. Which doesn't make sense. That's the response has to be like that. Say, inside the property as such as say, good, next up, like, be admitted. Agree to be admitted is percentage or percentage. Percentage of the game, and percentage maybe if you are to market to the people, find out the common
Shall we resume all the participants? Hope you are back. Yes, madam. I hope, madam, everyone is back. So let us resume our session. Now we will come to the future. Why I am saying future is still it is not completely deployed where everybody using 5G, right? So there will be various reasons. I would like to tell you, madam, I think some part is missing. Yeah. I think this is fine, madam. The previous, no, this is very small. The earlier one is fine. Okay. Now we are talking about the important challenges. You can just go through the complete slide, madam. You can click yes, yes. Yeah. One more. No, no, no. Yeah, here you stop here, madam. Thank you. there are majorly three key areas which 5G is targeting. Now, when you talk about 2G to 4G, 4G gives very good data rates even when the user is in moving state, or when the user is mobile, it will still give a premium data rates. But one of the key challenge is the second one, ultra reliable. Okay, let me cover the first one. Mobile broadband is already available. Mobile broadband, that is MBB, is already available with 4G. Now they are talking about enhanced mobile broadband. What is this enhanced mobile broadband? They want the latency less than 1 millisecond. Just imagine the latency, the promised latency of 5G is less than 1 millisecond, which is unimaginable, right? And when you talk about enhanced mobile broadband, they want more capacity also. For example, let me come to one point here. When 5G research started, almost maybe from the year 2020, I think. Sorry, 2010. I think from the year 2010, the research for 5G started. By that time, IoT is existing in the world. The concept of IoT is already there. So when people are coming up with the 5G network standards, they already kept IoT in the mind, and they already foreseen that when before the IoT, the number of devices that are getting connected are less when compared to with IoT. With IoT, everything is connected now. People initially we used to say Internet of Things. Now people are saying Internet of Everything. That means anything can be connected to everything. It became like that. So the number of device here need not be a mobile. It can be a laptop. It can be a sensor. It can be anything which gives data to us, right? When you are talking about such massive or enormous amount of devices being connected, you need something else which the 4G could not support. That is what here enhanced mobile broadband is all about. They want the mobile broadband services with faster connections and higher capacity, right? And then what is ultra reliable low latency communication? I will tell you, I think in the year 2008 to 10, in between, I'm not promoting. You all know the movie, there was a Tamil movie called as Yenthiran, right? Yenthiran means in Telugu, Sanskrit, it is Yantram. Yantram means machine, that's robo. Not the 2.0, I am talking about the Chitti Robo Aishwarya Rai movie. Okay. In that, in one of the scene, you see the vision of that particular director. In one of the scene, this particular robo, the Chitti Robo, he will perform some operation. He will live telecast the womb to the person, and they will be telling the remote instructions, and this guy will be, I hope you are able to understand what I am saying. Even in the 3 Idiots movie also, it is not graphically represented. Even Amir Khan also will try to give birth to a person where remotely he will be hearing. So what I mean to say is, in ultra reliable low latency communication, one of the application area is remote surgeries. Nowadays, people are already in the trials. If you go to the YouTube, okay, you can see there are some videos which will show a person doing the surgery from remote area. That is one of the application of this particular point number 2 here, what you are seeing. They need reliable communication, not reliable, ultra reliable. Why? Because in between, if any internet is gone, see, if internet is gone in my session, I can reconnect. But just imagine in there is a delay in some remote surgery. Patient may die. So in such case, what is required? Low latency is required, but highly reliable communication is also required. So for mission critical applications, you need to give uninterrupted, robust data exchange. That is one of the key challenge that has been taken by the 5G. Then the next one, as I said, when the number of devices are being increased, if you go to the Google and just type what are the number of IoT devices forecast, you can see there are exponential growth in the number of devices that are being connected. But you have to give the best in class service for all the devices. That is one of the key area which is shown here as number 3, that is massive. Massive means number. Machine type communications. What is machine type communication? MTC has another we call as M2M, machine to machine communication. M number 2 M. M2M, another way of expression is machine type communications, where two or more machines will communicate without the intervention of any human being in a peer-to-peer network manner. So to support such things, I will tell one more simple example. Now we are talking about autonomous cars, self-driving cars. Now in self-driving car, one car which is going on a road has to talk to the car which is going ahead of it. It has to talk so that how they will talk to each other. There will be a sensor or there will be a signal, and depending upon the reception time of the signal, it will calculate the speed of the car which is going ahead of me, and automatically if a car which is going ahead of me is applying brake, continuously this is sensing the thing and it should sense that he is applying brake. See, right now when we are traveling, if any red light comes in the back rear side, we will also apply brake. No, same concept should happen automatically. That means a machine, a car is talking to another car. Like there are so many other things like in industry, which I am going to talk about very soon. There are so many areas where people are now completely biased towards automation, right? For all those things, 5G is the promising future. Ma'am, go to the next slide, please. So this is how, madam, you can zoom to 120 or 130, please. I'm extremely sorry, madam, that I'm giving a lot of thing to you. Madam, there is a plus or minus symbol. No, there you can. This is very good, madam. Yeah. Now you can see in the left hand side, connected community. What is this connected community? Okay, let us see one by one. Let us go to in the middle, in the exactly middle of the left diagram, you can see hospitals. Something is written smart health, shopping center, school, safe vehicles, stadium, smart utility. If you closely observe, in the top left corner, smart home. After that, there is a big tower. If you observe, near the tower, it is like omnidirectional signal symbol is there. Omnidirectional symbol. But you observe some more areas where near the stadium, there is a small, on the footpath of the road, after the smart utility, on the footpath of the road, there is a small headlight kind of thing where that is a small cell I am talking about. Here, if you can observe, some communications are happening from the small cell, some communications are happening from the micro cell, where you are able to connect the communities together. In 5G, people, you can see in the right hand side also, it is going to provide high speed, low latency, right? Where all the businesses can be getting several opportunities from the 5G, which is not seen before. Go to the next slide, madam. Madam, next slide, please. Madam, you can directly show slideshow, right? That will be better, so that everybody can. Yeah, because every time if you are zooming, yeah. Madam, you can put in the slideshow, madam. I think that will be fast. Okay. So till now, the physical, what do you say, physical limitations were there till 4G, where everything is geographically located in one place. But in 5G onwards, people are moving towards the cloud architecture. You know, cloud computing, all the basic details of it. So the core network will be on the cloud. You can see clearly 4G macro. In the diagram, you can see 4G macro, 5G macro, 5G small cell. So all are located here. In 5G, there is a macro, 5G, there is a small cell. Similarly, 4G, one way it is representing heterogeneous networks. In another way, in the right hand side, you can see the radio access network will have both macro cell and massive MIMO. MIMO means massive input, massive output. You can see the tower symbol in 4G is different to the tower symbol in the 5G. You can notice the difference. The 4G macro symbol means it looks like a tower and the direction is omnidirection. But whereas in 5G macro, you can see instead of omnidirection, it is going to a particular place. For example, one is going to the car, one is going to the home. I hope you are able to understand what I am saying. So earlier, till 4G, everything is moving in omnidirection. The radio waves in the wireless medium, that is air, is going in omnidirection, where there are so many intersymbol interferences like refraction, diffraction, etc., where, for example, if you are, when I am calling somebody, the waves are going in all directions, right? So sometimes it may hit a mountain and come back, sometimes it may hit an opaque body, and sometimes some signals will be absorbed. You understand? But in 5G, which I will tell you maybe in the next slide, there is a difference between the way the signals are going. Okay. So here you can also see the central server is in a cloud, the local server is in a cloud. So everything is based on the entire 5G architecture. The radio access network is also called as CRAN, cloud-based radio access network. And in radio access network, the macro cell is there, massive MIMO. What is massive MIMO? It is very simple. Multiple antennas are given in a place where you can support the enormous number of devices that are being connected. More number of means I am not a complete electronic person, so maybe a EC faculty will be able to better express. But what I understand from MIMO, the massive MIMO, is you have more transmitters and receivers in a place where it can connect more number of devices when compared to the 4G macro. That is one device. And one more thing is beam forming and beam stealing. Okay, one slide is there. That time I will explain that. Now here you can see in the cloud network, in the right hand side you can see the core network is based on cloud-based network slicing and network function virtualization. Means basically network slicing is like a bread is sliced and given to multiple people. Similarly, your network is sliced and some private organizations want a piece of network. So you can dedicatedly give them. Okay. And because of the cloud, all the network functions are, cloud is coming from the concept of virtualization. So you can understand that network function virtualization is a means one domain where you can also write your own protocols. This is also one research area for a CSC graduate, CSC faculty, right? Where you can also write your own protocols, etc. Madam, can you go to the next slide, please? Okay. This slide is a simple representation that 4G will still exist with 5G till there is a point where everything is completely deployed in 5G. That is what this slide says. So 5G, when it comes, it will complement 4G. It will not throw 4G away. That is what it shows. Okay. So, for example, when there is obviously when there is no 4G network, we are able to still connect into 2G or 3G, right? Similarly, yeah, go to next slide, madam. We will, I think we are running out of time. We have to, yeah. It is a simple slide taken from internet here. You can see the comparison of 5G. Suppose if there is a movie, okay, Star Wars movie, which is nearly 4 GB. For a first generation, nobody used to download in 1G, but I'm just comparing. It will take nearly 5 months, whereas theoretically, the maximum speed provided is 20 Gbps, where 4G movie will come in 1.5 seconds. Right now, I am able to download a movie from Amazon Prime in 3 minutes in a remote location itself. So you can imagine the speed which 5G will provide. Next slide, madam. Madam, next slide. Yeah. This is one. I am not sure how many of you are from Visakhapatnam. The first 4 photos are taken from Visakhapatnam area where the Hudhud, I think 1, 2, 3. This is Visakhapatnam airport. The central photo which you are seeing, that is the roof is already gone. No, that and the below photo and the side one is from Visakhapatnam Hudhud Tufan time. Why I kept this is, for example, recently also we had a tragic train accident. Sometimes the buildings are collapsing, right? Imagine if your entire network is based on the macro cell, and if any problem comes and if the tower is gone. Why I am choosing this is during that time there was a news when Prime Minister Modi came, his phone is not working because all the signals are gone. Why? Why? Because people used to rely more on the existing macro tower networks, right? In case of disaster recovery, right, there should be another alternative. One of the research use case, madam, next slide, please. One of the research use case, okay, where you can also work upon is device to device communication. What you can work on, it is also called as D to D. Now, what is this D to D? Okay, it came from the concept called as direct communication. Then what is direct communication? Everything is direct only, no. Here, direct refers to without using the licensed spectrum. You know, there are 2 spectrums. One is the licensed spectrum, which we, right now what we are talking, no, it is through the licensed spectrum. But there is another thing called as ISM band, which most of the military people and all will use. Researchers also will use. That is unlicensed band. A simple example I will tell. Without SIM card, Bluetooth will come. Without no need of any SIM card. No need of any mobile network. For example, my laptop has a Bluetooth enabled. So there is no SIM card here, no? What is Bluetooth? Bluetooth works under unlicensed spectrum. It is not wrong. It is not unethical. It does not need, for example, your Wi-Fi device. It does not contact to the external world for the internal communication. But that is restricted to only few segments of people. For example, defense and researchers only. For example, many of you know train. Earlier, the guard used to wave the flag. Later, they used to show the lamp. Now, no flag, nothing. They will only have walkie-talkie. Cello means they will start. Stop means they will stop. That is called as TETRA, Terrestrial Radio Access System. The walkie-talkie. In military also, sir, I want to talk to you, over. Like that they will talk. Why? That particular thing cannot be tapped because it is working under unlicensed spectrum. So those things are called as direct communication. So what is direct communication? Without the interference of the macro network, can I use a communication? Why we need to do this? There are one reason I will tell you. For example, you are in CSC department. There is another department called as IT department. You want to call them. They are very nearby. Imagine 100 meters difference. You are using Vodafone. They are also using Vodafone in the same area. Even if you are calling, your thing will go to the tower, from there to BSC, from there to MSC, again from MSC it will come back to the BSC, and again from the same tower, and then only it will go to them. So people are thinking, can we use the licensed spectrum and skip some part of the macro cell? That concept is called as device to device communication. This is one of the potential area where we as a computer science engineer or EC faculty can write our own, means research proposals for getting projects, or you can come up with some idea where you can also work on some means guiding some students or doing any collaborative work with the like-minded people. Ma'am, go to the next slide, please. Yeah, you can skip the theory, madam. One diagram will come. Next slide, please. Some of the theory part, I think you can also go through. Yeah, this one is very important. There are standard right now. All the references are given in the end of my slides. So wherever I am studying, you can download those articles, and definitely you will get more data from this. Okay, there are 4 kinds of device to device communication that can happen. It is very, very simple. We help each other, right? As human beings, we help others. Similarly, in case, let us talk about the first one. The first one is device relaying with operator controlled link establishment, DROC. The left hand side, first one I am talking about. Okay, here the source is very far away from the base station. Imagine, source is very far away. So it can use the intermediary mobile device and pass the information to it. That is what, you know, relay concept, right? In the athletic race also there will be relay. 4 people will be waiting, but all will not start the race. One guy will come and give one thing to the second guy, then only he will start. So that is called as a relay race. That means cooperatively they are running. One race done by 4 people. Similarly, but the link establishment will be done by the base station. Link establishment will be done by the base station. Then now let us see the second one. Here, directly source and destination are communicating. The second one in the right hand side, DCOC, that is direct D2D communication with operator control link establishment. Now this is communicating directly, but the link establishment is done by base station. Below 2 diagrams are neither the link establishment is done by the base station nor the data transfer. One is direct. So Qualcomm is one of the company which is coming up with a protocol called as LTED. LTE is advanced, right? LTED is long-term evolution direct device to device communication. There are enormous works going on this. Okay, I am about to submit one project proposal also based on this device to device communication for smart water irrigation management. Okay, so there are so much of potential. You can go through it, and these are all infant, not exactly infant, I should say. These are the potential areas where you can get lot of possibility, and you can get lot of visibility also if you are working on such areas. Madam, next. See, this much of concept is required to understand what is IoT here. Till now you may get it out. This guy told IoT, but he never mentioned any IoT, because all these things are supporting IoT, which you will easily understand. So here you can see there are a lot of possibilities like autonomous drones, the virtual reality, industry automation, autonomous vehicles, telemedicine, etc., etc. Ma'am, let us skip this, right? Yeah, go to the next slide, madam. The new spectrum is used in 5G, that is above 6 GHz. till now, I will not spend more time here. Okay, the frequency which we are going to use for 5G is more than 6 gigahertz. Ma'am, you can skip this. Go to the next slide. But remember, 5G is above 6 hertz. Now, what is this beamforming? As I said earlier also, now you observe the left-hand side 4G macro. It is omnidirectional, whereas you see the 5G macro, multiple beams are formed and it is exactly pointing. This is a concept called as beamforming, and depending upon the movement of the user, dynamically the beam pattern will be adapted. So for this, because of this technology, what you are going to fetch, the benefits are less interference, less noise, and more good, more appropriate services to the, or more premium services to the users. Next slide, madam. Now, how this 5G will impact Internet of Things? Okay, as massive number of devices are getting connected, 5G can be able to support them. One more thing I forgot to tell you. In an example, to take an example, how best the data rates are provided from 5G. For a low mobile user, it is 10 Gbps per second. For high mobile user, you know what is high mobile? Over and above 350 kilometer speed, 5G is going to offer 1 Gbps dedicated, means theoretically. If one person is there and he is moving, he is going to get 1 GB for a high mobile user, which is not supported by 4G. 4G can support good mobility for 250 to 350 kilometers, but 5G is targeting beyond that. Now, initially, IoT came for simple applications, very simple applications, not mission critical applications. I am talking about 2010, not now. Slowly, IoT became mobile IoT. What is mobile IoT? For example, let us take an autonomous car system. All the cars are IoT devices, they are moving. Right? Now we are into industrial IoT, industry 4.0 people say, right? So all those things I will cover in another half an hour time, which is left to me. So there is another protocol called as LTE-M, or new band IoT, narrow band IoT, where people are now concentrating on how best this 5G can support IoT. As I said earlier, IoT started already, they exist. Sorry, excuse me. IoT was existing in the year 2010, where the 5G started. So 5G is completely based on keeping in the view of IoT in a massive manner. Madam, next slide, please. I'm extremely sorry, madam. I'm giving a lot of pain to you for moving the slides. So mobile IoT, how it is going to look like? As I said, smart cities, smart mid. Nowadays, everything people talk about smart. You talk about traffic, people say smart traffic. You talk about agriculture, people talk about agriculture. I will tell one simple example. You can write a project if you want. I just share an idea. If it is, I am not sure whether it is there or not, but this is just an idea. Okay. If you are able to pursue, you can write a project, or you can also think about it. In many places, where are some of the places, the traffic signal I am talking about in a major cities. Some, sorry, not some, many places, the traffic counter is common. For example, three minutes. Everything is 3 minutes. Sometimes we may observe there is a Chaurasta, 4-line road. 3 lines are full, 1 line is empty. Still, the traffic signal will not change. It will not allow, oh, nobody is there. So let us allow. So you can also come up with smart traffic system where there will be camera. Camera will take the photo. Photo means the image of the traffic, and immediately it is sent to the server. Depending upon the density of the images, dynamically it can decide and allow the traffic. So that is a smart traffic signal. Means everything is smart now, no? So all those things can come. And critical communications, as I said, autonomous vehicles are mission critical because if there is any delay, no, one car will go and crash the other car. Okay, and factory automation. Now in Industry 4.0, people are now using robot. In many places, people are using, for example, food processing unit. You see how many packaged foods are coming from the human being hands. Nothing. Even the pork industry, chicken industry, all the meat industry, everything automatically. The chicken will cut and automatically it is just everything. I hope you understand what I'm saying. So go to the next slide, madam. Mobile IoT is going to be supported from 5G in a crater. Madam, this particular slide you can skip. Already I have spoken the examples. Yeah. Yes. Here, non-public networks. As I said, due to the network slicing, you can give a dedicated IoT frequency bands for various people. For example, if you have a production industry, right? As I said, if you need more secure and reliable network, you can have, instead of sharing the network which is open for public, you can also slice the network and create one dedicated non-public network which is exclusively meant for a particular industry. Okay, they are also called as private networks. You can, or enterprise networks like military, hospitals, university, etc., etc. Madam, next please. Yes. I have taken this from one of the IEEE transactions or IEEE communication magazine. Now, if everything gets doubled or tripled or exponentially increased, how come, sir, radiation will come down? Many people will ask, sir, 5G is dangerous. There were so many rumors. If 5G comes, everybody will die. One of the example, I'm not taking negative example, good example only, the Robo 2.0 movie. What is it all about? It is all about let the other living beings of the nature live along with human beings, right? Why that Shankara has taken that concept? That's also a good concept where, but there are so many regulatory authorities where people are working on models in such a way that the radiation level will not become dangerous. Now, when the number of electronic equipment increases, for example, instead of one tower, now we are talking about one tower and multiple femtocells. How come the environment will become greener? One of the article here it shows, as I said already, in case if you use femtocells, because of the small coverage area, the amount of energy that has to be disseminated from a device will be very less, and automatically the radiation will become less. And as of now, you can see in the right hand side, one of the content I have given, it has proved that the amount of energy requires is very negligible, and carbon emission, etc., is also less. That's what they are saying. Now, you can go to the next slide, madam. How femtocell will be used in an Internet of Things? How femtocell can be used in Internet of Things? Yeah, one diagram, madam, you show. One diagram only. Yeah. Let us see the first diagram here. People started with femtocell. Now, in the year 2013 itself, I read some articles 10 years ago. I read some articles about mobile femtocell. When the standard femtocell came, now people are talking about mobile femtocell. Same example here. For example, let us see the second bullet point: public transportation vehicles. Here you can see in the diagram there is a bus. On top of the, or inside the bus, or on top of the bus, you can have a femtocell. When the bus moves, femtocell is also moving. That means it is a mobile femtocell. What is the advantage of that? See, now, when I'm not sure how many people have heard, in Bangalore, 10 years back, or yeah, 10 years back, people are getting stuck in the traffic. when I am working in Bangalore. Now it is more pathetic. People are talking about, can we have a bus where you will get the Wi-Fi facility so that the employee will sit and keep on coding. It looks very funny and pathetic also for them who are working, but that is also a technological concept where such kind of a mobile femtocell can be used. All the people who are sitting in the bus will get connected to the femtocell and that will communicate to the macro cell. You understand? No. In case if you are coming down from the bus, then you will get connected to the macro cell. Or if you are keep on going, then you can still get a premium service. You know, in Japan and China, you know about bullet trains. As I said, in 5G, the promised speed is more than 350. Also, it should get 1 gigabits per second. So one of the article, I think in my references, I might have given one of the IEEE article long back, 10 years back, I am telling. It has published some concept where mobile femtocells can be there in every compartment, one femtocell, and on top of the train another femtocell where these femtocells will talk to that and that will pass the information to the external world. Now you can see the right side diagram. How mobile femtocell can be used for health services. For example, I have a body area network. I have a wearable shirt and pant where there are so many sensors. My heartbeat, my BP rate, etc., are being done. Then in my house, I can have a femtocell and my readings can directly given to a doctor. It can be given to a intermediary family member or an ambulance or a health center. I hope you are able to understand how femtocells can be used in the concept of Internet of Things as well. This is another case study where you can work on body area networks as well. Madam, next slide, please. I think we have 21 minutes time. So as I said, mobile IoT is becoming the heart or the part of 5G. Madam, you can go to the next slide. I'm really thankful to you, ma'am, that you are keep on exchanging my slides. So as I said, initially, when there was no internet, people used to simply send an SMS or call somebody. When the internet came, now people used to browse or people used to communicate in email, etc. Now slowly, completely, the face of IoT has changed dramatically or in an exponential manner where anything can be connected to everything. Madam, can you please go to the next slide, please? Go to the next slide, madam. This is only a, I think people can read later on. Now, when IoT has arrived, how the 5G will change? As many times I have explained the concepts how IoT is going to have a great support from 5G. Madam, next slide, please. It is going to connect numerous devices in very less amount of time. Okay, so as I said, high availability, strong security, deep coverage, high density area will be covered, ultra low latency, high reliability, multiple gigabits per second data rates also will be provided, etc., etc. Next, madam. So I think I have already covered such kind of slides already. So we can skip this slide, madam, because I have one more presentation to show you. Yeah. I think this also covered, like in self-driving cars or automotive and mobility aspect, your IoT comes into picture. And for example, in case of, definitely we will see already Waymo company, which is from Google in US and all. I was amazed to see we have an app, you book an app like Uber. We are booking an Uber cab or an Ola cab, right? A person is driving. Similarly, Waymo is a company from Google. You can see in the YouTube videos, one customer will just have an app. They open, select the location, and it will give the exact time when car will come. Self-driving car will come exactly there. She sits, she can listen to her own music, and exactly it is taking her to that particular place. So this is also possible. This is already there. We are not seeing as of now, but we are going to see very soon. Next slide, please. So as I said, the 5G enabled traffic safety service, right? When it comes, you can have different small cells which are definitely getting connected to the macro cell also, because nearby communication will be handled by small cell, further communication will be handled by the cell. You can see in the diagram that so many warnings are coming. This is all I have already told in the theoretical part. Now only slides are coming. Okay, so you can see all the information. This is one of the best example of IoT with your 5G, right? Just imagine, definitely after 10 to 15 years in India, you will see many cities without any manual driving. Definitely you will see cities with only self-driving cars. Just imagine how much of data will come and what the face of IoT is going to be. Next, madam. So these are various business case opportunities, right? The last one is fixed wireless access. See, fixed means wired. Wireless means no wire. But what is fixed and wireless? It is very simple. Giving the data rates in terms of wireless with respect to the data rates what they were promising in a wired communication. That means even though it is wireless, you are going to get the promise of what we used to get in the wired communication, right? There are so many manufacturing other industries. Madam, next slide, please. Yeah, this part is already covered, like connected farms. This is one more use case where you can see the macro layer also, and also the small cell where everything is connected together. Next slide, madam. Next slide, madam. This is already covered, madam. Next slide. Next slide, madam. Because I have to open in another 15 minutes the other one also. As I said, in Internet of Things with the 5G, self-driving, I think it is already covered. I think, ma'am, you can please skip. Skip, madam. And I will cover this in the next slides. Yeah, this is more important. 1G, madam, only click one time, madam. Don't click all at a time. One click. No, this is fine. In this, yes. 1G is where all it began. Correct, madam. Correct, madam. You click one click at a time. Yes, next click. 2G is the cultural revolution. 3G is the packet switching revolution where the more premium data services started. 4G is the streaming era. Right now we are in 4G streaming era. That's why it is able to, we are able to connect now in this FDP. And 5G is going to be termed as Internet of Things era. Ma'am, can you open the other slide, madam? I have another one too. There I will show only few things. References is fine. So these two, there are two slide decks I am going to use. Okay, this one and one more one. Ma'am, you can close this slide and open the other presentation, madam. No problem. In that presentation, I will show only few things. Some things may be repeated also. These two slide decks will be shared to all the participants. So my official and personal email ID, and I have only one phone number. So in case if you want to have any collaborative research work, I am open for that. Any research related discussions, I am okay with that. Let us see the other slide deck. Few slides only I will explain from there. Now, I have a question. When everything is connected to internet, there is one problem, that is security. If you are opening everything in the internet, the first issue anybody will tell is it secure? Now you are saying your car is connected, your mobile is connected, everything is connected to everything. Okay. So some of the slides I will skip here. Okay. Because some 5G related things will be there. Because this is two different slide decks. Some common things will be there. Now let us think about industrial Internet of Things. 5G is okay, IoT is okay. What is the difference between Go to the next slide, madam. What is the difference between IoT and IIoT? In a simple manner, I will explain. Initially, when IoT came, it was not defined for mission critical applications. But whereas your industrial IoT, it can be healthcare, it can be agriculture, it can be productive manufacturing, or any other things. All are mission critical applications where, in general, initial days IoT devices are dumb devices. What is dumb devices? I will just pass the data to you, you receive it, process it, and give it. That's all. But now the devices are becoming smart or intelligent in a way. They take some decision making also with amount of some analysis being embedded in that particular processing unit. Earlier, take the data, pass the data, take the data, pass the data. But nowadays, people are now, not nowadays, from earlier also, industry, IIoT is not a new thing, okay? But IIoT is exclusively meant for mission critical applications, okay? Madam, you can go to the next slide, please. Next slide, yeah. So lot of theory is there here in this one. Yeah, lot of theory is there. I am explaining in a summarized manner. Later you can also study. As I said, use of this main IIoT is you need to remove the dumb devices and make the devices smart enough so that some amount of data analytical capability is also embedded inside the devices. Go to the next slide, madam. Yeah. IIoT devices will have four important entities. One, in the middle of in the second button, second bullet point I am telling. First thing is connected devices. Second, you may have a private or the public data communication infrastructure. And then I said in industrial IoT, the analytical capability to generate information from the raw data is also embedded. Then the storage, basically without storage, what we are going to process, and the people. Okay. Here in IIoT, the devices are intelligent enough not only to pass the information, but also to analyze the data from the history and do some business analytics as well. Next, madam. The next, madam, you can skip this, madam. So what are the industries? There are so many industries, for example, automotive, agriculture, oil and gas, etc., where you can just imagine by instead of putting human beings and all, and people are now relying more on, then somebody may say, sir, if you remove all the people, see, always there is a potential to change the face of the industry when science is getting involved. Some people will talk about the other way where, sir, no, sir, it is not correct and all. Let us not go into that debate. No, madam. Next slide, madam. Basic building blocks for IoT. One, the sensor. Basically, without sensor, there is no IoT. The ability to connect. How we are going to connect. Then a software application where the program, everything, coding comes into picture. What it has to do. Next one. Next slide. Fast and available network, and there should be a cloud and a data analytics capability. So You can work on cloud. You can work on application. There are these 6 areas are there. Somebody who is very good in physical layer, they can work on sensors, how they are communicating. Somebody who is very good in network layer, they can write some protocols or they can improvise the existing things. Somebody who is good in virtualization techniques, they can work on the cloud-based services that are being offered. Some people are good in data analytics, they can work only in this. Or we can bring together, for example, one person is very good in communication aspect.
Hello, sir.
If you have a capability of communication, somebody may have capability of working in cloud, somebody may have capability in network layer. So we can all together also, we can collaborate, and some people can see sometimes collaboration makes real wonders. So I urge all the faculty to think about it. I'm not asking to collaborate only with me. You can have like-minded people, you can collaborate together, and you can do multidisciplinary research as well. Yeah, go to the next slide, madam. There are so many roadblocks. No. Yeah, impediments for adopting complete IIoT is there are so many roadblocks. These are the roadblocks, right? When you are bringing so many technologies together, or you want to change the existing setup to match the IIoT, you may have hardware incompatibility, or you have to spend a lot of money for installing various sensors. And the basic mindset, the human mindset, is also need to be conquered, right? So the connectivity issues, this is always there. Now you can see 2-3 times I got disconnected, right? And the last one, which is the most important one, is if everything is open to internet, is my data secure? Is privacy promised or not? What kind of data security issues may come? Go to the next slide, madam. I have 5 minutes time now. If I have to start, no, you can go to the next slide, madam. Yeah, let me directly here, madam. Yes, wait, madam. Now, these are 3 main areas where you can think about security aspect. For example, you can have the mobile telecom networks where you have the radio access network, that is the base station controller, etc. The core network, transport network, and interconnect network where these layers are connected. Okay, then each network will have, for example, I think the control plane where the control signals are passed, the user plane where the actual traffic is there, and the management plane where the management means there are so many other things apart from your data. There will be other data also which will be going on. Now, ma'am, go to the next slide, please. There are 3 places where you have to secure the data. Next slide, madam. Next. Yes, this is the place. There are 3 places. 1, data in use. That means your server is running, for example. So your server got the data. So data in use means at this particular server also the data needs to be secured. When your data is being received and being processed, this is one area where you can work upon security aspects. Not only that, Data in motion has to be secured. What is data in motion? For example, your data is coming to the server. In between, that is in between place is the data in motion. You have to. This is another area where you can also work upon. Another place is data at rest. For example, you have taken a backup and stored in a warehouse. There also potential problem may come where you have to. So your integrity, availability, and confidentiality are three entities where the security will be defined. For example, confidentiality means you have to protect the data when it is in use, when it is in transit, and when it is in backup stage. Availability means it should be highly available, or even though if there are any network outages. For example, we know about high availability system, active server. If one server is down, another server will take up. For example, you know about fault tolerant systems and all. Such thing is there. And integrity is another aspect of security. That means even though the data is there or coming, we have to make sure it is not changed in between by any unintended user. So there are so many researchers going on. Madam, next slide, please. Next slide, madam. Next slide, please. Next slide. I think these slides we will skip because 5G. Yeah. So flexibility, reliability, low latency, and high throughput are the new major characteristics of 5G NR. NR means new radio, right? A different spectrum above 6 gigahertz. Okay, beam forming, beam steering. These are all coming under 5G. Yes, ma'am. Next. So yeah, ma'am, I think we are running out of time, so we can skip this. You can read by yourself. These are the 5 core properties: resilience, communication, security, and all. You can, I think, from my references also, you can see from where I have prepared many concepts from the internet and various research articles. So all the references are given. If you follow my references, you will get the full content from where I have prepared these slides. Next slide, please, ma'am. But many of the slides I have already explained, and there are so many security challenges. As I said, all those things needs to be addressed, and people are working on that. This is one more area. Some people are very good in network security and cryptography, so they can work on how we can secure the network when 5G is going to support all the things in the cloud-based system. Next slide, please. I think from here, I think we can. Next, madam. I think all those things are covered. I think only. Next, madam. Okay, next, madam. I think that is. I think I am done, madam. I am done. So I am not sure how much amount of information I have given to you, but this is a huge topic where 5G and IoT, the various use cases, different research areas, and all. So to my level best, I tried disseminating the little knowledge what I have. Now I give the session back to Professor Suma Madam. I would like to thank all the faculty who are participating in this program, and I would like to exclusively again thank Professor Jay Suma Madam for giving this wonderful opportunity. Now I will give the session to queries and other formalities of the FDP. Thank you, everyone, and you can share your valuable feedback so that if I have to change anything, I will try to improve myself. I might have rushed a little bit because the topic is very huge.
Thank you, sir, for your valuable and informative session, sir. So I think you have given lots of knowledge and information about IoT, IIoT with real-time examples, sir, to our participants. Thank you so much, sir. Dear participants, if anyone having any doubts or queries, please unmute yourself and ask to sir.
Thank you,
Am I
madam.
audible?
Yeah, yes, madam. Thank you, madam. You are audible, madam. Yeah, anybody can unmute and you can ask some queries or any research collaborations or any research thoughts. And in case if I am unable to answer, definitely I am available to you. And these 2 slide decks will be shared with all the participants by Professor Suma madam. You can close the slides, madam, I think.
Okay, sir.
I think the participants does not have the permission to unmute, madam. In case, because the session is over, in case if there
Yes,
is a
sir.
possibility to give them permission, I think then it will be better because I can see participants cannot enable their mics, I think.
Okay, sir. Okay, sir. I will check.
No, sir. Session going on. Oh, JNT विजयनगरम करके एक तो है स्टेट यूनिवर्सिटी है उसमें 5G and IoT का टॉक चल रहा है. Good.
Finish नहीं
सर
finish नहीं हुआ
कोरिस जा रहा है सर.
आपका कोई whitener है
What?
whitener
सर व्हाइटनर तो नहीं है.
छोड़ दीजिए
व्हाइटनर नहीं है सर.
okay fine
व्हाइटनर नहीं है. Yeah, faculty, kindly unmute yourself and you can ask any queries or any valuable feedback. Sir, your voice is not clear.
Okay, sir. How can we see wireless sensor networks and IoT?
Sir, IoT is based on WSN only. If there is no wireless sensor network, there is no concept of IoT. Nowadays, people want a fancy term only. So people are not talking about WSN, people talk about IoT, but without wireless sensor, without sensors, there is no IoT, sir. So you can say WSN is the father of IoT.
Okay, okay, sir. Thank you, sir. Thank you.
Yes, sir. Any other queries or your valuable feedback? Your feedback will help me. You can say negative points also, no problem, because then only I can improve myself. So in case if you feel something is wrong in the way I am explaining, you can feel free to share me. And I would love to hear from you. Like how
Participants. If anyone having any doubts, please raise your hand so that I will make you as a presenter, please.
for example, there are some software tools I'm not promoting anything here. Like you can say MATLAB. Similarly, there is something called as NetSim, Network Simulator. It's a proprietary item from a company called as TEDCOS. So it has device-to-device communication. It has somebody is speaking, so I will stop. Let me just complete. There are some tools which may help us in writing our research articles or research proposals, right? Like example, NetSim. Completely, the entire software is based on C language. They have 5G also module. They have M2M. They have D2D. Like NS2, NS3. There is something called as NetSim. So depending upon your requirement and your university support, you can use the tools and you can change the protocols. And definitely there are so many potential areas where you can work with 5G and IoT. Yes. Bhavani madam has raised hand. Okay.
Hello.
Hello, madam.
Sir, you have completed?
Yeah, I'm done, madam. I am only
Okay,
waiting
sir.
for the.
Okay. Any of the participants having any type of queries, please? Please ask the questions. If any one of you are having.
Yeah, one of the participants, Sushma Rani, has raised hand, madam.
Okay.
I think you have to enable the
Jyoti,
mic.
please. Jyoti, please enable all the mics.
Okay, ma'am.
So that they can interact with the resource person.
Anyways, we have ample amount of time. My number is also shared. So offline also after this, any kind of research discussion, you can also text me in WhatsApp as well. I think somebody is going home in the bus, I think. So I think, madam, we will wind up from my end, I think.
Okay, sir. Thank you, sir. Thank you very much
Thank
for
you.
your valuable time as well as sharing your expertise regarding IoT 5G era. Thank you very
Thank you, madam.
much.
Thank you. Thank you, madam. Thank you, everyone. Jai Hind.
Thank you, sir.
Thank you, everyone. Jai Hind.
Ma'am, shall we close? Thank you, participants, for your active participation. The next session will starts on tomorrow, 2 o'clock. Thank you.
Madam. What? Sir. Okay. Transfer